Hello, my name is Chase Berline, and together with Ryan Dole, we are researching the elemental composition of the plant germ Cycladenia via ICP-MS. A little bit about the abstract. We're analyzing the elemental uptake of the plant germ Cycladenia, and this is done by an ICP-MS instrument to find the concentrations of the plants. This is done by separating the plant by three sections: the top growth of the plant, the middle growth of the plant, and the bottom growth of the plant, including the gel, which is transported in. Um, and the results show which material is best fitting for the growth of the plant with the composition of the section. A little bit about the background of the plant. It is shown Cycladenia and is commonly found in southern Utah and northern Arizona. And the plant was listed as threatened under ESA in 1986. And there's little to no information about the age of these plants, and no seed germination has ever been observed.
Further on the background, seed banking is typically for plants. It preserves genetic information and diversity, and it can be stored for hundreds of years to protect against disease, drought, and endangerment. Some plants, such as the Jones Cycladenia, does not have the ability to have seeds preserved in a seed bank, and without that ability, seeds can become endangered and possibly extinct. For our research purposes, we are trying to find which elements react positively with the Jones cycladenia to determine better preservation strategies, and um, we're also trying to see and analyze the elemental composition and growth patterns to see which element can lead to a healthier plant and one that could possibly be part of a seed bank due to the Jones cycladenia as of right now not being able to be in a seed bank.
Here are some of the materials and methodology used for this research. We received our plants from the Cincinnati Zoo, and some of the materials that were used were 100% nitric acid, vials and caps, beakers, pipettes, burettes with clamps, razor blades, the ICP-MS machine, Agilent 7700, ethanol, DI water, volumetric flasks, scales, and for safety, nitrile gloves and goggles.
How we prepared our standards were that we made sure that, well, the ICP-MS needs a baseline for the standards. So we took a series of serial dilutions and internal standard procedures. And we basically made 500 ppb of the nitric acid and then diluted that down to different ppb ranges so that we could get a good calibration curve for it. As for the sample preparation, we removed the growing medium for it. And then we separate the plant into the top, middle, and bottom of the plant, the bottom including the gel. And then we weighed each component and let it digest for 23 hours in 50% nitric acid. And that was done in a sand bath at 70 degrees Celsius. And then these samples were run through the ICP-MS spectrum. We actually still need to do that, and we'll get the results next week. In this graph, these are just the elements that we were looking for. And then in this graph, it's a good visual example of how we need to dilute the 500 ppb down to each for the calibration curve.
And this is how we received the plant vials. As you can see, there is the gel and then the plant growth, and more on the separation in the next slide. This just shows how we cut up the plants. As you can see, we go from the gel to the top layer of the gel, and then 1 centimeter above the gel line, and then the rest is just considered the top of the plant.
And this is just a visual representation of the ICP-MS machine. You can see the key components on the side. Main thing to know is that it uses a giant tank of argon plasma, and that allows us to get the hyper-specific results and to see each individual element and how it works with the plant.
As for our future goals are to actually run the samples through ICP-MS and to analyze the data and find correlations between element concentrations and potential plant growth.
Okay, and that was our presentation. Thank you.
Thank you.